Please let me introduce myself. My name is Adil Vega. I am in my senior year. I am in my last semester here at CSU. I am pretty excited to be done. My major is electrical engineering. I wanted to take a class like this for a long time. I have always been interested in the mechanical integration for electrical engineering projects and automation. This is the field I want to work in. So, without further ado, this is my presentation for my project for Engineering 300 3D Printing Lab for Engineers. I'm going to start by presenting a little bit of background on my project. For my project for this class, I worked with a biochemical engineering PhD candidate. Her project consists of building a system that will detect distinctively different types of pathogens on the field and air quality. This is to be done out on the field. The project calls for several types of sensors to monitor data. In order to hold the sensors in place, a chassis is needed. The sensors have irregular shapes, so an off-the-shelf solution does not exist. During this semester I was delegated the task of creating the chassis for her project as well as other circuitry for it. The technology of additive manufacturing was an ideal solution to create the chassis needed for her project. It would help to achieve some of the key goals needed during the lapse of this semester. The purpose and goals of this project can be summarized to three main goals. 1. To create a custom chassis to hold sensors that come on irregular shapes and to hold a microcontroller responsible for performing the necessary calculations and data. As mentioned before, an off-the-shelf solution is not available to be used for her project. 2. To be cost-efficient and faster to produce. Having to send the model off campus for manufacturing and wait several weeks was not ideal for her project since several revisions were going to take place during this semester, and some sensor may be needed to be replaced with other type depending on their performance. And 3. To be easy to modify for future revisions. Since this project is going to be a long-term research, it would be highly beneficial to have a master file where revision could be made without consuming a lot of time, especially since the chassis design is going to be passed to someone else next semester. Form, fit and function. Here to the left, the front view of the chassis shows where the three main sensors are located. The sensor marked as 1 was the most time-consuming to model since it has a particularly irregular shape. As mentioned before, the additive manufacturing was ideal for creating a part around this sensor. The other two are marked as 2 and 3. These other two were easier to model, but they still are irregular geometry. In this next slide, the back view of the chassis can be seen. On the back, the placement of the microcontroller can be seen. It is the object on white color. This is not my model of the microcontroller. This model was found online. It has some amazing detail. I can't imagine how long it took for someone to make, unless they used some laser scanning to produce it. Here are some pictures of the actual prototype with some sensors and the microcontroller on it. This is the final revision for this semester. The filament used was PLA. PLA was used mainly because of the cost, and because it was an easy material to work with. In addition, PLA could be used on a number of printers I had access to. From the Senior Design Lab for Electrical Engineering and a personal printer. Features and highlights. As mentioned before, the material used was PLA. It took around 11 to 12 hours per chassis to print with a profile of 0.15 mm with a weight of 94 grams. The smoothness of the chassis was not a constraint, but after some experimentation, this profile was easy to work with. And this profile helped to reduce the printing time of the units. Weight was also not a constraint for this project. The printing time was long for one piece but a lot shorter than sending it to be manufactured off-campus. Time was a little more of a constraint because of the number of units needed for her project, and the deadlines. The cost of every unit was $4.70, a cost of 5 cents per gram. Well under the budget designated for chassis on the project. There was minimum warpage on the chassis as it can be seen on the picture. I tried to use different bed temperatures and blue painting tape to reduce the warpage on the models. However, the corners had the tendency to develop some warpage. It would have been perfect to have no warpage. However, the amount of imperfection was not critical for the performance of the unit. The edges were sharp and it required minimum filling to fit the senses. The main reason for the need to filling was to remove residual material from the supports created for the floating sections on the model. One highlight that I will like to mention is that by splitting in half the model, I could use different printers that had a smaller bed size. I used a TAS-6, where the model fitted without a problem, a Mini from the Senior Design Lab, and my personal PowerSpec where the bed size is smaller and the model could be fit if was cut on half. As the project needed a total of 12 chassis, therefore by doing this I could have 3 printers running at the same time, reducing the time to produce all 12 chassis. Lessons learned and mistakes. Some of the mistakes I made during this project were setting the STL file resolution wrong. Too low created a pixelated model making the model deformed. And on the other hand, too high resolution creates a very large file. Having a large file created problems for the slicing program. It crashed every time during slicing. Using the wrong wall thickness. By reducing the wall thickness as a method for trying to reduce the printing time resulted in creating a model that was too fragile and the printing fails during operation. Another mistake was to simply set and forget. During some of the first prints, I will set and start the print. Usually at night. I will watch for the first 2 layers for any fails and then leave, only to come back in the morning and find a mess of filament all over the bed. Some things I would do differently if I will have to make this project again would be: first, spend more time creating a good quality STL file in order to reduce the time spent on fixing errors later on. Basically more planning and less trial and error. Creating custom support for floating sections. The automatic support created by the slicing program is good, but sometimes it puts it in places where it can be done differently. Another thing I would have done differently is to use Octoprint to run the printer. This would free up the computer and a camera can be set up to watch the print online from other location and have the ability to stop the print if there was something wrong occurring with the print. Well, this all for my presentation. Thank you for your time and attention.